this function, let's say maybe modulus of x minus 2 its modulus, or maybe let's say mod x plus 3, or some combination of these two, let's say modulus of x minus 5 plus 7. So how to draw the graph of these functions? So this is called as graph transformation. So how the graph actually behaves. These are slight changes in x's that we are making. In the basic function, slight changes we have made. Mod x was my basic function, mod function. In the mod function, slight changes about the x point we have made. So how the graph behaves, this we will study in this chapter, transformation of graphs. Okay. So let's study the shape of some graph. A slight introduction about this point we have already seen while doing the analysis of the quadratic equations. When we did the analysis of quadratic equation, quadratic graph of a quadratic function. At that time, I told you some point like this. If x square graph is something like this, how the graph of x minus 1 whole square will behave, then how the graph of x minus 2 whole square will behave here, then how x square plus 2 will behave, x minus 1 whole square plus 5. That was a slight introduction of transformation of graphs. Similar, this thing that we studied for analysis of graph, actually this was transformation of graphs that we were studying. Now we will study that property in details. Okay. So just 1 second. Yes, now the screen should be visible. Okay. So just two graphs that I want to tell you is trigonometric functions graphs we have not seen, and the exponential graphs we have not seen. So first I will tell you the exponential graphs, and then we will see the trigonometric functions graph. So for boards, the graph of exponential and logarithmic function is not there. So exponential function, if it is given to you, f of x is equals to a to the power x. Now a to the power x, there may arise two cases. Okay, f of x is equals to a to the power x. First case, when a is greater than 1. A is greater than 1. This is my first condition. And the second condition is, sir, a is less than 1 but positive. Okay, between 0 and 1. Like logarithms, so do you remember we used to take two conditions? The base of the logarithm lies in the interval between 0 and 1 and strictly greater than 1. So these two cases we will draw the graph. The graph in these two cases is my y-axis. Can you see that, sir, a raised to 0 when x is equals to 0? So the graph will be 1. X raised to 0 is 1. Okay, this point is 0, 1. When x is equals to 0, the image will be 1. Okay, so this point will be on the graph. And also, can you see, for example, let's say, sir, when x makes a jump of 1 unit, I will always make x a jump of 1 unit only, a fixed jump along the x-axis. What is the jump along the y-axis? Sir, jump along the y-axis. For example, consider a is equals to 10, let's say. So jump along the y-axis. Initially, it is 10 raised to 0, 1. Then 10 raised to 1 is 10. Then 10 square is 100. Then means initially the jump is of 9 units. Then the jump is of 90 units. The jump is of 9,000 units. So can you see that? Jump along the axis, axis. The jump along the y-axis is going on tremendously increasing. So the graph is something like this. it's a smooth curve. A smooth curve. This point is 0, 1. What I was trying to convey using this jump method means here 1 unit, here 1 unit, here 1 unit, but the correspondingly along the y-axis, initially this jump is of 1 unit. Okay, sir. Now from 10 raised to 0, this jump, this jump, this jump, the corresponding jump along the y-axis means this jump I'm talking about. This distance is always going on increasing. Can you see this point?
Yes, sir.
Okay. These are the corresponding points of x equal to 1, images of 1, images of x equal to 2, images of x equal to 3, images of x equal to 4. The jumps along the x, how much difference you're going in the y-axis direction. That is the difference of 1 and 10, 10 and 100, 100 and 1000. That is increasing. So the graph is something like this. Okay. And for the a line between 0 and 1, for a line between 0 and 1, again for x is equals to 0, y is equals to 1. Graph will be over here. And so when x is 1, let's say x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equals to 5, and so on. Consider a is equals to half. A is equals to half. Consider a is equals to half. So can you see that, sir, x is equals to 0, 1, 2, 3, 4. Y is equals to half raised to 0 is 1. Half raised to 1 is half. Then we will take the power. As I will go on increasing the power, the image value will go on decreasing. It will become more and more of a fraction. While teaching logarithmic inequalities, I told you this point. A proper fraction when multiplied, you are taking a fraction of a proper fraction, means when we are raising it to power. So the image is going on decreasing, decreasing, decreasing. So the graph will be something like this. Do you agree with me? It will be approaching 0. Here it is. This is the graph of a raised to x when a, the base I am giving a constant to be between 0 and 1. This point is x equal to, for x is equals to 0, the image is, okay. Do you agree with me? The graphs?
Yes, sir.
Okay. And now the domain and range of these functions. Domain is equals to the complete set of real numbers, because everywhere the exponent is defined. Okay. The x, for whatever x you give, positive, negative, x can be anything, positive, negative, 0, anything. So for each and every value of x, the a raised to x is defined. And the range function, can you see that the graph is always above the x-axis? Above the x-axis, the purple line graph is always above the x-axis, means it can take all the values of y which is above the x-axis. So range is always greater than 0. Anything greater than 0 will be is achievable. Anything greater than 0 is achievable for y. Y cannot be negative. Is this clear? Here also the same thing. Domain is equals to set of real numbers, and range is equals to everything from 0 to infinity. The graph, the purple line graph is all completely above the y-axis, completely above the x-axis. So it takes all the y values above means 0 to infinity. Okay. And another thing for this graph, you can say that this graph is monotonous. Monotonous graph means what? Monotonous graph means it's a well-behaved graph. Means when x is increasing for a greater than 1, for consider for this example. So when x is increasing, y is also increasing. It's a continuously increasing graph. It never happens because sometimes the graph is going upwards, that is image value is increasing, then the graph comes downwards, that is the image value is decreasing, then it goes upwards. It never happens this way. Continuously it is increasing. So this is a monotonously increasing function for a greater than 1, and for a between 0 and 1, so this is a monotonously decreasing function. A very nice function. It is continuously decreasing as x is going on increasing. It is continuously decreasing. It does not behave randomly that sometimes increase, sometimes increase. No. Okay. So exponential function this, and now on one graph only, if I draw multiple exponential functions, if different a's are given to you. So just a comparison I will tell you. This is the graph of, let's say, the power x. Okay. Then the graph of 3 to the power x, it will also pass through 0, 1. The graph of 3 to the power x will be something like this. The graph of 5 to the power x will be, it's a smooth curve. Don't go for my drawing. It's a smooth curve like previously only, a smooth curve. The graph of the blue, that is 5 to the power x. Or let's say, so what point I want to convey over here is the, as a goes on increasing, a greater than 1 it is there, but in that also if a is, as you're going increasing, the graph in this first quadrant is shifting leftwards. Now sir, how to remember this point? How you have to just remember, sir, for x equal to 1, take any x is equals to 1, x equal to 2, or x equal to 3. Take any fixed value of x, let's say x equal to 1. Can you compare, sir, 2 raised to 1 will be greater, or 3 raised to 1 will be greater, or 5 raised to 1 will be greater? You can clearly see that, sir, 5 raised to 1 will be greater than 2 raised to 1. For that matter, you can take the 2 raised to 1, this will be there. So means, so the image, the is the image on the blue point. The image on the blue point should be higher up then the image on this 5 raised to 1 is the image on the blue point. 3 raised to 1 is the image on the purple graph, and 2 raised to 1 is the image on the black graph. Means what? So black graph, y-axis image, black image should be lesser than the purple image, should be lesser than the blue image. This way you can, if the doubt arises, which graph will be 2 raised to x, which graph will be 3 raised to x, you can convince yourself this point. Okay, black point will be downwards for a fixed x. Corresponding purple point will be upwards. This will be 2 square, the purple point that I've drawn now, that is 2 raised to 2, and 5 raised to 2 will be even higher up because 5 raised to 2 will be the greatest value among the three. Okay, so case here. And try thinking for some time for here also. Let's say now for this graph, let's say a is between 0 and 1. Okay, so try to how the graph compare, how the relative positions of the graph will be there for 0.9 raised to x, 0.8 raised to x, and 0.7 raised to x. How the relative positions will be there? Try thinking for some time. I will draw these three positions. The graphs will be, all the three graphs will be in this manner and passing through 0, 1. But relative positions, how it will be? Now, how to think? Sir, if I take, let's say, x equals to 1. So 0.9 raised to 1 and 0.8 raised to 1 and 0.7 raised to 1. So 0. This will follow. 0.9 raised to 1 is always greater than 0.8 raised to 1, 0.7 raised to 1. Similarly, for x equal to 2, the corresponding images, so 0.9 square, 0.8 square will be smaller, and 0.7 square will be even more smaller. So the black image, the black point image, the purple point image is smaller. Purple point image is smaller means it will be over here. And the blue point image will be even smaller. Blue point image will be somewhere over here. So can you see that the graph? So the graph, it should pass through 0, 1. The blue point image. Blue point image will be what? This will be 0.7 raised to x, or this will be 0.8 raised to x. Okay. Is this clear? The current comparison of graphs, if the relative positions, if A is with respect to A.
Yes, sir.
Okay. So this is the part of exponential function. Now the inverse function of exponential function is logarithmic function. So f of x is equals to log x to the base a, and again f of x is equals to log x to the base a. First case, sir, a is greater than 1, and the second case, sir, a between 0 and 1. So first thing you should see that, sir, this graph in logarithms we have already seen, so log x to the base a, when x is always greater than 0, only then log x to the base a is defined. So sir, since x is always greater than 0, the graph can never be in this region. For these points, x equal to -1, -2, -3, the graph, there is no image. So there is nothing in this part. If at all the graph will be there, it will only be in the first and fourth quadrant. Now, how that graph behaves? At x equal to 1, log of 1 to the base, and the graph is something like this. So this is the graph of log x to the base a if a is greater than 1. A rough explanation I will give you how to get this feeling. So means now see here we will think in the reverse direction. Means I have given you the step type of explanation for this. It's how to convince us. So x is going on the step along the x axis if it is constant in the exponential function I'm talking. The corresponding increases in the y is very high. For the constant increases in the x of 1 unit, 1 unit, 1 unit, the corresponding increases in the y is in the corresponding increase in the y images increases initially from 0 to 1, only of 1 unit increase. From 1 to 10, the jump is of 9 units. From 10 to 100, the jump is of 90 units. Then 100 to 1000, the jump is of 900 units. So here, similar approach, I will tell you that why the graph is this way. So log x to the base a is equals to a. Now don't think of it in terms of I will see the jump along the x-axis. Think of it is a if. So log x to the base a is y. Na? Log x to the base a is my y. So if I go on increasing my y by one fixed constant unit 1. So y is equals to, let's say y is equals to 1, 2, 3, 4, 5. So jump is of 1 unit along the y axis. So y is equals to 1. What was the image? This point. Y is equals to 2. This image. This was the corresponding x. Y equal to 3. This was the corresponding image. Y equal to 4. This was the corresponding image. So what is the jump in the corresponding axis? So initially the jump was this much, then the jump was this much, then the jump was this much, then the next jump will be even greater since the graph is becoming more and more horizontal. Then the jump will be even more greater. Can you see this part? The corresponding jump will be even more greater. So why is this happening? Because see, log x to the base a means sir y equal to 1, 2, 3, 4. X is equals to, sir, let's say consider a is equals to 10. Log x to the base 10 is equals to y. So 10 if y is equals to 1, can you see that x equal to 10, y is equals to 2, x equal to 100, y is equals to 3, x equals to 1000, y equal to 4, x is equals to 10,000. So if the jump in the y is constant, the corresponding jumps in the x is very much high. So it goes on increasing. So the graph goes on flattening. It moves on. A little bit Hindi if I speak, then you could say that y एक्सिस में इमेज में सेम इंक्रीज करवाने के लिए मुझे x को ज्यादा बढ़ाना पड़ता है. इनिशियली सिर्फ 10 से 100 बढ़ा लिया तो काम चल जाएगा. इनिशियली if I just increase my x from 10 to 100, let's say from 10 to 100, the corresponding y will increase by 1. But after that, I will have to increase it by 10 to 1000 to make the corresponding increase of 1. This is a just logical explanation. And this is the graph. Okay. See, this graph never goes completely flat, 100% flat. It never goes. It's always going on increasing, but approaching flat. Okay. So domain is equals to everything greater than 0 up to infinity, because for x equal to 0 or less than 0, there is no image. The domain is for what values of x is the function defined. It is greater than 0 up to infinity, and the range log x to the base a can take all real values. Can you see that the purple graph, it takes 0 value, negative values and positive values, each and everything. Okay. The range is R. And here for a between 0 and 1, convince yourself that the graph will be this way. This point is for x equal to 1, the image with this point is x equal to 1. This point is x equal to, for x equal to 1, the image is 0. Okay. Is this clear?
Yes, sir.
These are the exponential and logarithmic functions. And now we will go to transformation of graphs.
Sir, you said you will say trigonometric function graphs also.
Yes, first let's do transformation of graphs and then I will tell you trigonometric functions graphs also. Today actually I want to start with transformation, then we'll do trigonometric graphs also. We will do trigonometric graphs and the inverse of trigonometric together. Because inverse of trigonometry is slightly introduction I will have to teach you. Transformation of graphs. Now let's see, if I first give you, let's consider simply with a mod example. If I just tell you, let's say y is equals to mod x. This graph every one of you know. So how this graph behaves? This graph is something like this. This is my x and y axis, and the graph of modulus of x is this way. For x equal to 1, the image is 1. For x equal to 2, the image is 2, and so on. For x equal to minus 1, also the image is 1. For minus 2, also the image is 2. No doubt in this. Now, if I ask you what will be the image, what will be the graph of modulus of x plus 2. So can you convince yourself this point that sir mod x plus 2, this is my graph. Mod x graph, sir, I already know. Mod x graph I already know. If I consider, so let's say x is equals to 0. Initially the graph was something like this of mod x. Okay, this is dotted line, is the graph of mod x. Now, so what will happen? This mod x graph, at each and every point of x, whatever what you're telling, this was my initial image. Now x equal to 1, my initial image. Now I will have to add plus 2 units to it. So I will shift this point 2 units upwards. I will shift this point 2 units upwards. This is, let's shift my 2 units, 2 units. This point will shift 2 units upwards. This point will shift 2 units upward. Can you see that the graph will go this way? This vertical distance is 2 units. So for this vertical distance is 2 units. This vertical distance is 2 units. Why? For each and every x, so whatever was my initial value of mod x, this was my initial value of mod x, I have to add plus 2 to get the new value of, to get my new image. What is my new image is mod x plus 2. This is my image. Here also the same story will be repeated for negative x's. So the graph is shifting completely 2 units upwards along the y-axis. And mod x, let's say y is equals to modulus of x minus 3 if I tell you. modulus of x minus 3. So what was my graph of mod x? Mod x graph was something like this. This was my graph of modulus of x minus 3. Can you convince yourself the graph will shift downwards by 3 units?
Yes, sir.
This is my graph of mod x minus 3. This is my graph of mod x. Clear? So if I have, let's say now on a single
Sir, one
graph,
scroll down, sir.
okay, Pujita?
Okay, sir.
So if I have any random graph, let's say this is my graph of f of x. Okay, this is my graph of y is equals to f of x. So the graph of f of x plus 2. F of x plus 2 and the graph of f of x minus 3. So f of x plus 2 will be, each and every point will be shifted 2 units upward. For x equal to this, the graph will be shifted upwards. X equal to this, graph will be shifted 2 units upwards. X equal to here, graph will be shifted 2 units upwards, 2 units upwards, 2 units upwards. Can I say that the graph will be something here? This point, this was my, let's say, point, whatever this point was, it will be shifted 2 units upwards. It will come over here. So the graph will be something like this. And for f of x minus 3, the graph will be shifted 3 units downwards. This is the first transformation. F of x plus something, f of x minus something. Okay. Is this clear? This is the first transformation. This was the example I first explained it with the example of mod function. And now this is for any random shape. F of x, it can be any random shape plus f of x, what that shape, that basic function shape, you know, plus constant and minus constant. If you did the relative position, the graph shifts along the y-axis, upwards or downwards. Now, second, let's say, so y is equals to mod x. I know y is equals to mod x. The graph is this way. This is my graph of mod x. What will be the graph of y is equals to modulus of x minus 2. Initially, what we were doing? Initially, we were doing mod x plus 2, or let's say mod x minus 2 maybe there. For the function we were adding or something. Now, I'm taking modulus of x minus 2. Now what you will do? Now here, now it was something like the graph will be, can you see that now center of my point, the center of my initially the graph will, now the graph will be over here. The graph shifts to the right side, 2 units. So why does it shift right side to the 2 units? Means initially this was my graph of mod x. Now the graph shifted to the right 2 units. Why did it happen, sir? Sir, x minus 2, consider it to be my z. Okay. Initially, whatever was the image of x, now to get that image of whatever the image of x, whatever the image of x was giving me, to get that same image, I will have to make my I will have to make that z to be equal to x, because now my graph is mod of z. I'm plotting y is equals to mod of z. On the x-axis, I have to take modulus of, don't think about the z-axis. I'm just thinking on the x-axis. I have to take the value of z is equals to initial. Let's say if initially if x is equals to 0 was giving me the image as 0. Now I have to take z is equals to 0. And in order to make z is equals to 0, I will have to take x is equals to z plus 2. Graph shifts right towards. This is the logic. Can you agree with me on this point?
Yes, sir.
For x equal to, I will just give you, let's say, comparatively better explanation would be, sir, if x is equals to 1, the image was 1. Now, in order to obtain x is equals to 1, the image as 1, inside the modulus, whatever complicated expression is there, that value should be 1. The same image 1, this image, vertical image 1, I will get when inside the complicated expression, inside the modulus, whatever complicated expression you gave, that value is 1. And when is that value 1? You will have to take x, this x minus 2 is completely 1. When x minus 2 is completely 1 means what? X will be equal to 1 plus 2. Means this image I will have for this 1 plus 2. Means somewhere over here, 2 units to the right. 2 units to the right, here I will have the same image. Okay. Let's say equal, here it was x equal to minus 2, the image was 2. To have this very image inside my modulus, I should have negative 2. For the new expression, inside the modulus, I should have negative 2. For to make inside the modulus negative 2, my x should be what? My x should be negative 2 plus 2, that is 0. So plus 2 means I'm shifting 2 units to the right side, 2 units to the right side over here. So now I will have the corresponding image over here. Okay, every time you're moving 2 units to the right. So this is the graph of mod of x minus 2 and y is equals to modulus of x plus 3. So some mod x will be something like this. Modulus of x plus 3 will be what? Modulus of x plus 3 will be, center will be shifted 3 units to the left hand side. Exactly same, the v part which is there, it will have the same angle between them, no changes, it will just be shifted parallelly. See the graph of modulus of x plus 3. Okay, Dhananjay and Pujita. So now if I give you any complicated expression, any complicated graph.
Sir, one scroll down, sir.
Okay.
Sir, 1 minute. Done, sir.
This is the graph of, let's say, y is equals to f of x. Y is equals to f of x. So how the graph of f of x f of x minus 3 will look like? For x minus 3, the graph will shift rightwards or leftwards? Think for some time. How to process this information? See, the thought process I'm telling you. So for, let's say, x is equals to 0, x is equals to, the image was what? Point downwards, whatever is, let's say, x, the y is -2. For x equal to 0, the image was -2. Now, sir, now, if my inside this expression here, if I get the same value of that, this complete expression 0, if it is equal to 0, this complete expression, when it will be equal to 0, then I will get the same image -2. So when will that inside expression be 0? That inside expression will be 0 when x is equals to +3, means 0 plus 3. So for corresponding here, this -2, the brother of this x equal to 0, this x equal to 0, its brother is 0 plus 3. Let's say maybe over here is +3. Its image will be negative. So for, let's say, yeah, the graph shifted. The graph is shifting to the right side by 3 units. Is this clear to everyone? And if I give you, let's say, f of x plus 2, the graph will shift to the left side. Left side at same height. Exactly, nothing changed. This will be the graph of f of x plus 2. This is the second transformation. When x is shifted, means x, there is a change in f of x and f of x plus k and f of y is equals to f of x and y is equals to f of x minus a, or let's say x plus. This is the second transformation. Now the third transformation is, let's say y is equals to,
Sir, one scroll down, sir. Done.
now let's say y is equals to f of x. This graph is given to you and I am asking you how the relation between y is equals to f of x on the basis of the graph of y is equals to f of x. Draw the graph of f of minus x. How this graph will look like. If you plot f of x and f of minus x on the same graph paper, how they will be related with each other. For example, consider now this will not relate. Now this will not try to understand using the mod example or let's say any one particular function. Now any general function. Well, let's say the graph is this way. This is my graph of f of x. This is some random shape. It's some function, it is some random function. I did not bother what it is. Okay. Now, if this function, if this is the shape of f of x, and now I'm telling you, plot the graph of f of minus x on this very axis, on this same very graph, on this same graph paper. F of minus x, y is equals to f of minus x, plot on the same graph paper. Now, can you see that, sir, if x equal to 1, let's say, if x equal to, let's say, this point is 3, if this point is, let's say, 5, this point is 6. Sir, when x equal to 3, I had a corresponding image 0. When x equals to 3.1, the image was a circle. The x equal to 3.2, the image was a circle. X equal to 3.2, the between 3 and 5, the image, the corresponding images were going on this way. Okay. So, sir, when now I have to plot the graph of f of minus x. F of minus x. So, sir, if you actually plot the graph here, so means now f of minus x, I am plotting on this x-axis. Okay. So, sir, when here in this, if I substitute x is equals to 3, x is equals to 3, so I will have to take the image of what, sir? I will have to take, if I substitute x is equals to 3, I will have to take the image of minus 3 point. Okay, means f of 1, 2, 3, 4, 5, 6, so on. So for x equal to 3, the corresponding image will be, sir, f of minus 3. Now I am plotting the blue graph. Now the black graph I have already plotted, and now I have to plot the blue lines somewhere. So the blue lines when I'm plotting for x is equals to 1 here, where to plot the blue, where will be the blue point corresponding? It will be image of -1. For x equal to 2, the blue point will be image of -2. The for x equal to 3, the image, the f of x will be, the image will be f of -3. So think of it in this way. Let's say image of -1, image of -2, image of -3, image of -4, image of -5, image of -6, image of -7, image of -8. I have to plot. I am plotting f of -x. Okay. I am actually putting x equal to 1, and I am getting, in order to find x equal to f of, means in order to find x equal to 1, I am to plot the graph of f of -x. When I put x equal to 1, I have to plot f of -1. So what is f of -1? Sir, f of -1 is this point. Now I have to go on seeing this graph. So it will be something like this. It will be a mirror image. Or let me make the graph little simple. 1 minute. I will make a simple graph that way. Understandable. Okay. Let's say this is my graph of f of x. So f of -x, if I want to plot. When I take x equals to 1, do I need to plot the blue lines? I have to plot. So when I have to plot the blue lines for x equal to 1, for x equal to 1, when I will have to plot the blue lines, what I will have to look at? I will have to look at, sir, f of -1. Do you agree with me? So, sir, what is f of -1? Sir, f of -1 is somewhere over here. This is my f of -1. So this point I will have to plot over here. The same height. So for x equal to 2, if I want to plot the blue line, for blue line, if I want to plot the blue line, sir, the corresponding blue image of x equal to 2, the corresponding blue image of x equal to 2 will be f of -2. And f of -2 is what, sir? F of -2 is over here. So this point I will plot over here. For x equal to 3, the corresponding blue point, the corresponding blue image will be, sir, for x, f of -3. For f of -3 is over here, it will be over here. For x equal to 0, it will be one and the same thing. Initially, f of 0 and f of -0, it's one and the same thing. So the graph will be this way. Do you agree? Actually, how we were behaving in the -1, -2, -3, -1, -2, -3, how you went in this direction in -1, -2, -3, or actually for the blue line, that is how you are going in 1, 2, 3, 4, 5. And so for now, x is it for the 2 point x equal to -1 to plot the blue points over x equal to -1. I have to look for f of 1. What is f of 1? Okay, f of 1 is over here, sir. F of 1, this point I will plot. So for x, to plot the blue image of x equal to -2, for the blue image of x equal to -2, I will have to look at f of 2. F of 2 is upward over here. This graph will go this way. Do you agree with me? Is this clear that how the graph is coming symmetrical mirror image about the y-axis? f of x and f of minus x. Pujita Dhananjay, clear?
Yes, sir. Yes, sir.
So the graph will be f of minus x and f of x and f of minus x. The graphs are mirror images about y-axis. Same, f y is equals to f of x, and another thing that you have to plot is y is equals to, initially we plotted f of minus x. Now you have to plot minus of f of x. This is a very easy graph. This is my graph of f of x. Now you have to take f of x with a negative sign. So sir, if x is equals to 0, if x is equals to 0, initially this was my y, this was my image. So now you have to take, for to plot the purple point. To plot the purple point, you have to take the f of x image and just invert its sign. Just take the opposite sign. So the whatever distance you have gone downwards, go that much distance upwards. For x is equals to 1, if you're going 2 unit, for if the image is -2, if the image is -2, now the image in the purple point, for the purple point, the image will be +2. For x is equals to, let's say, 3, if the image is -2, now the image will be +2. If this point is 4, the image is 0. The image is 0. Then the, for x equal to, for the purple point, again the image will be 0. For x equal to 0, here again the image will, for this is this point, this image won't change. The image is 0. For that, let's say that x is -1. For x equal to -1, the image is 0. For in the purple graph also, the image will be 0. Graph, now here also the image will be same, whatever that point is. Now here in the x equal to, let's say -2, -3. So for x equal to -2, the graph was going upwards. The image was positive. For the, in the purple graph, in the purple image, the purple image of x equal to -2 will be negative. The purple image will be negative, so it will be downwards. For x equal to -3 also, the purple image will be negative here. So f of x and minus of f of x, they are water reflection about x-axis, or mirror images about x-axis. That also one and the same. Water reflection about the x-axis. Okay. Clear, Pujita? Should I scroll down?
No need, sir. Done, sir.
Okay. Y is equals to f of x is given to you, and you have to plot the graph of y is equals to f of x, its modulus. This one is the easy. The next one will be difficult. Next one I will give you. Y is equals to f of x is given, and you have to plot y is equals to f of modulus x. Okay. This is mod of f of x and this is f of mod x. Write the two questions together and then we'll see the graphs. So now if let's say my graph is this is my x-axis and this is my graph of f of x. Now, can you see that first of all in the purple image when I will plot, my purple image is always positive, irrespective whatever is x. I don't have to bother. So x can be negative. For x equal to -2, if x is equals to -2, whatever is the image f of -2, I will just have to take its magnitude. F of will be defined. The image of x of -2 will be positive. So x is equals to -3. The image will be positive. F of -3, whatever it may be, positive, negative, I don't know. F may be positive, F may be negative, but modulus will become positive. So the purple graph will always lie above the x-axis. Purple graph will always lie here, first quadrant and the second quadrant. Do you realize this thing? Purple graph always have to be positive. The purple images will always be positive, so it should be above the x-axis. So sir, if x is equals to 0, if I take for x is equals to 0, whatever my depth was, the depth is, let's say, -3, means the image is -3 in the black graph. So now the new image in the purple graph, the image will be +3. For x equal to 1, the image was, for x equal to 1, the image was -3. For x equal to 2, the image was -3. In the purple graph, the image will be +3. So for this point, this point, the image will be 0 only. The graph will come. Is it clear?
Yes,
Whatever
sir.
graph went downwards, it just came upwards. After that, what? After that, now here the black graph is already above the x-axis, above the y-axis, above the x-axis. The black graph is already positive. Means f of x is already positive in this interval. Means its modulus, it's one and the same thing. The purple graph image and the black graph image is one and the same. So here the graph will overlap itself in this interval. Here also it will overlap, no problem. and in between here again it will come up. This whatever part was downwards, it became a water reflection. The part where the black graph is downward, it comes upward in the form of a water reflection. Here it will be something like this. And then again in the when x is greater than or equal to 0. And what about x less than 0? So same logic. For x equal to -1, if the graph was negative, here the image f is negative, the black graph is negative, but we have to take modulus of f. So the same thing will be repeated, just it will come above. This point will be over here. Let's see. After this, what to do? Always do first thing first. Wherever the image is 0, mark those points. Those points remain fixed. They do not move. Here, mark this point. Means why I am telling you this. Once you arrive this, once you took water reflection till this point, you face a confusion, sir. Now what to do ahead over this? Should we go this way or should we cross something like this transformation? Because we have studied so many transformations, so we get confused. Just remember, when f of x is 0, they won't change their values in the modulus sign. So when it is negative, it's coming upwards, this downward. Here it is already upwards, and then here black goes negative, the black graph becomes negative, so its modulus will be positive. Is it okay? This purple graph is the image of, this purple graph is the graph of modulus of f of x. Okay?
Yes, sir.
Done, Pujita? Shall I scroll down?
Answer.
Okay. Now, f of mod x. F of mod x you may confuse with f of minus x. Here, f of x and f of minus x. These questions are all very much closely related to each other. F of x minus x. F of x and f of modulus x. This is my graph of f of x. Now, how f of modulus of x will look like? First things first, domain of f of mod x is the complete set of real numbers. Don't think, sir, that mod x is x should be positive only. If x is negative also, if f of x is defined for all real numbers, then mod x means what, sir? If you take x equal to negative, it will be f of plus, means it's defined for all real numbers. No problem in that. So now if x is greater than or equal to 0, so then if x is greater than or equal to 0, if you take x or mod x, they are one and the same thing. Modulus of x is same as x only, sir, for x greater than or equal to 0. So whether you are taking, sir, f of modulus of x, if you are taking, sir, f of modulus of x, actually, yes, sir, if you are taking f of x only, no, it's one and the same thing. So if I tell you for x is equals to 1, x is equals to 2, x is equals to 3, if I want to plot the blue images, for x equal to 1, if I want to plot the blue image, f of modulus 1. So f of modulus 1 is what, sir? It is f of 1 only. F of modulus 2 is what, sir? It is f of 2 only. So the blue images of f x equal to 1, 2, 3, 4, 5, 6, 7, 8 is actually the same as black images. The blue image of x equal to 1, 2, 3, 4, 5, 6, or for that matter 0 also is same as black images. Do you realize this? So for the graph to the right side of y-axis, the graph will exactly overlap each other. No change. Okay, Pujita Dhananjay. And now what happens if x is negative?
Yes.
For
Yes,
x
sir.
is negative, if I want to find the image of x equal to the blue image of x equal to -1, the blue image, I will have to take f of positive 1. For x equal to -2, I will have to take, in order to plot the blue image of x equal to -2, I will have to take f of x equal to -3, I will have to take f of 3. Means where I will have to look? I will have to look for x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5. How there the graph is behaving? The graph of f. How where? How is the graph of f behaving? The black graph behaving x equal to 1, 2, 3, 4, 5. However it is behaving, means in whatever way it is behaving, plot that graph for x equal to that graph, the black graph of 1, 2, 3, 4, 5 as the blue graph of -1, -2, -3, -4. Means take the mirror image. Now this my drawing is bad. Okay. This will be the for x greater than or equal to 0, graph is exactly overlapping, and for x less than 0, just take the mirror reflection about the y. And so what happens to these values? The original values of f of -1, f of -2, f of -3, they become useless. They don't cause any difference to us. They are kind of they are kind of useless in the graph of f of modulus x. These values, that one that I have marked. Okay. Clear?
Yes, sir.
Yes, sir.
And now probably the last of this lot. Y is equals to f of x is given to you. Plot the graph of y is equals to this. Actually, I'm telling you the transformation of y is equals to some constant times f of x. So here we will take two cases. First case is y is equals to, let's say, 10 times f of x, and the other case we will consider y is equals to, let's say, half times f of x. So what's the difference? The difference is, in the first case, I'm taking the value of k, the magnitude of k, to be greater than 1. And in the second case, I'm taking the magnitude of k between 0 and 1. So what if k is negative? That I will tell you afterwards. Okay. What about if k is negative? First, we'll see only for positive. So now be greater than 1. Let's see. Chalo. This is the graph of f of x. And now for f of x, I have to, from f of x, I have to change to the graph of f of x. I have to draw the graph of 10 times f of x. First thing first, wherever the image is 0, the image I'm talking about, wherever the image is 0, that point images will not change. So here for x equal to 0, the image was 0. For x equal to here, whatever this point is, the image was 0. The purple graph image will remain the same point. For this point also, the purple graph image will come there only. For this point also, the purple graph image will come there only. First things first. Okay. Now, after that, when 10 times I'm multiplying, now I have to just multiply the original value 10 times. So now here, see, now this value, whatever is the peak value, it will go upwards. It will, this point I'm talking about, this image which is there, it will go upwards, 10 units upwards. So 10 units upwards means actually 9 units, whatever. Now if that value is 2, so it will become 20. So it has gone 18 units. The jump is of 18. The distance, this distance. So don't think that this line will be parallel. Means when initially for mod x and mod x plus 2 and mod x minus 2, mod x plus 2, what we were doing, so we were shifting the graph as it is. The shape was not changing. We were totally means shifting it upwards. Here we are not shifting the graph upwards. Means this line, it is not getting shifted upwards. It is changing its shape, because not each and every point is going upwards by 18 units. Means let's say if this point is, let's say 0, 2, means the vertical image is y, the black point image is y. Now the purple point image is 20, means 18 units jump is there. But here the image, the y image is, let's say 1. The purple point image is 10, means the vertical jump is of 9 units only. The distance it is shifting upwards, it's not same for everyone. Okay. So this graph is this way. We are not shifting it. It is getting stretched, kind of a stretch. It is kind of a stretch. Now here the purple image this way also, it is 0 only. So from x equal to 0 to, let's say, x is equals to 3. In the interval x equal to 0 to 3, it was a V-shaped graph, that it remained a V shape, but that curvature of that V changed. Initially it was a wide V, now it is a very narrow V. It became stretched. Okay. After that, here also, this top peak of the topmost point of that hill, it will go upwards by, it will get multiplied, and that topmost point, this will be this way. The graph will remain a u only, but it will be stretched. Here negative, here the negative point for this point x equal to, let's say 3 4, so this point for x is equals to 5. The purple black image was, let's say, -1. The black image was -1. Now the purple image will be even more negative. So the downward u is more stretched. And this graph was going this way, and now the purple graph will go this way. Clear? The graph becomes stretched kind of. And this way also, now I will draw for the x negatives y 0. This point will come over here. This point will come over here. This point will go. If I draw this way, it's a mistake. The lines won't be parallel. I have to stretch the graph. In this, when you are drawing it parallel, means you are telling that, sir, this shift, this distance, the red distance downwards shift and this downwards shift, it's one and the same. No, they are not same. This will be shifted more downwards. Here it is coming narrower. Got it? How graph changes for 10 times f of x? Clear, Pujita Dhananjay?
Yes, sir.
Yes, sir.
Okay. And now for half of f of x, I will draw the same graph. This is f of x. And now I have to plot the graph of y is equals to half of x. First things first, wherever the images are 0, those points will remain fixed. No changes in those points. Just say it's kind of, we are means we are putting a nail on those points. Don't shift them. We are nailing them to the x-axis. And now after that, you have to take half of this f of x. So this peak will come downwards. So can you see that the graph will be this way? I think this explanation should be easy from the previous one. This peak will come downwards. So the graph remains a u in this interval. Initially also it was a u. Now also it is a u. Just the curvature of that u has changed. Here also this, it will come this way. Is that clear?
Yes, sir.
Here the graph will come
Yes, sir.
upwards. Here the graph will come. Don't make here parallel, which is wrong. The correct graph will be this way. this one is wrong. Okay. Here it will go. This is the graph of half of modulus of x1. And now if you are having the question, sir, if the graph would have been minus 10 f of x, or let's say minus half f of x. What if k is negative? For positive k, I have divided the k in the two intervals, k greater than 1 and between 0 and 1. So what if k is negative? Let's say -3, -4. So -3 also if it is there. So you can plot the graph of 3 times f of x, the same thing, magnitude wise. Okay, 3 times f of x, and then just take the water reflection. Because you know what is the relation between f of something and f of that with the negative sign, minus of f. So here, if to plot the graph of minus 3 times f of x, I will, from f of x, I will draw the graph of 3 times f of x. And from 3 times f of x, I will take the water reflection about the x-axis to get negative 3 times f of x. Done? Yes or no?
Yes, sir.
Okay.
Sir.
So here the transformation, the theory is completed. Now questions, how the questions are asked over this question is, these transformations are generally useful for solving the questions of range only, domain and range of functions. But I will just give you, but don't get, we should not rely on the graphs to solve the questions of range and domain. This knowledge is important, but it is not, we should not get addicted to graphs. Means if I'm able to plot the graph, only then I will be able to solve the question. That is a very bad habit. So let's say the sample problem I will give you. Try this yourself. Modulus of x. This graph you already know. Very simple graph. Draw a rough sketch of first y is equals to modulus of x minus 2. You will be able to do this. Yes, sir, it's very easy. Okay. Then draw the rough sketch of modulus of x minus 2 plus 3. Yes, sir, this is also easy, I think. So I suppose you should be able to do this. If you are able to do the second question also. Try thinking, sir, how the graph of, let's say, minus modulus of x minus 2 will look like. That is okay. So how the graph of minus 2 minus, let's say, minus modulus of x minus 2 plus 5 will look like. Y is equals to negative 3 times modulus of x minus 2. Six, y is equals to four times modulus of x plus 4 minus 5. Actually, I wanted to give you this as the original question. This is the main question. In order to take you up to there, 1, 2, 3, 4, 5 are the baby questions, step-by-step questions. Think these step-by-step questions. They will serve as a hint for this main question. So I wanted to give you this as the, this is the actually for the first basic question is sixth one. In order to give you the introduction of the sixth sample question, 1, 2, 3, 4, 5 are the hint questions.